Hi guys, maayong adlaw. Welcome to NatzMath TV. So for today's video, my presentation is about solving quadratic equation by completing the square. This is now the last video for the 4-part series for solving quadratic equation. I already have a video about solving quadratic equation by factoring, solving quadratic equation by quadratic formula, and solving quadratic equation by extracting square root. So this is now about solving quadratic equation by completing the square. But before I proceed to my examples, please do not forget to subscribe, like, and share to your friends, especially those who are incoming grade 11 students, and of course, those who are junior high school students. So this lesson is for junior high school students, specifically for the grade 9 students. Okay, so to start, what is the square of 1/2 of the following numbers? For example, you are given the number 12. 1/2 of 12 is of course 6, and the square of 6 is 36. How did we get 36? We just simply multiply 6 two times, that means 6 times 6, which is 36. Another number is 3. 1/2 of 3 is of course in decimal, we have 1.5. But we will not be using decimals here. We will be using the fraction. So if we have 1/2 of 3 is 3 over 2. We just simply multiply 3 times 1/2. That would give us 3 over 2. Then the square of 3 over 2 is of course 9 over 4. That means 3 times 3 is 9 and 2 times 2 is 4. Another number. For example, you are given 5 over 3. To get 1/2 of 5 over 3, we multiply this by 1/2, of course. That would give us 5 over 6. Then the square of 5 over 6 is 25 over 36. Now, this concept will be used later in our discussion on solving quadratic equation by using completing the square. Another concept which is very useful in this topic is about the perfect square trinomial. For example, you are given this trinomial, x squared plus 10x plus 25. When we say perfect square trinomial, these are trinomials having first term as a perfect square and the last term is also a perfect square. So when we factor this out, we just simply write 2 parentheses. Then the square root of x squared is x. So we have here x times x. And we copy the sign of the middle term here, which is positive. So that's why we have here positive. Both are positive. And of course, the square root of 25 is 5. And when we add 5 plus 5, that would give us 10. So when we write these factors, since both are the same, we can write this one as the square of the binomial like x plus 5 quantity squared. Okay, another example. For example, you are given 4x squared minus 12x plus 9. So the first term is a perfect square, and of course the last term is also a perfect square. So when we factor this out, that will give us the square root of 4x squared is 2x, so we write here 2x and another 2x. Then we copy the sign of the middle term, which is negative. That's why these are all negative. Then the square root of 9 is 3. That's why we have here the 3. And again, both are the same, so we can write this one as 2x minus 3 quantity squared. Last, for example, you are given x squared minus 14x plus 49. So when we factor this out, that would give us the square root of x squared is x. So we have here the x times the x. Then we copy the sign of the middle term, which is negative. That's why both are negative. Then the square root of 49 is 7. And of course, when we add 7 plus 7, that would give us 14. So x minus 7 times x minus 7 can be written as x minus 7 quantity squared. We will be using these two concepts in our discussion about solving quadratic equation using completing the square. Let's proceed to our example number 1. For example, we are given x squared plus 14x minus 15 equals 0, and we are going to solve this quadratic equation using completing the square. Now, first step is to see to it that the first term has the coefficient of 1, meaning x squared, the coefficient of x squared should be 1. But if the coefficient of x squared is, for example, that is 3 greater than 1, we need to divide both sides of the equation by 3. Okay, so to proceed, we need to isolate the constant. In this case, our constant is negative 15. We need to isolate this constant to the right side of the equation. So how do we isolate this constant? Of course, since this is negative, we have to use addition property of equality so that this will be cancelled out and this will be transferred to the right side of the equation. So the equation becomes, we copy the first term, which is x squared. We copy the second term, which is plus 14x. And this is minus 15, of course. Since this is minus 15, we use addition property of equality. So we add 15 at this side of the equation so that we can cancel this out. This will become 0. And since this is an equation, we also add 15 at the right side of the equation. So the resulting equation becomes, we copy the first and the second term, x squared plus 14x. So this is now 0. Then we have at the right side of the equation, 0 plus 15 is of course 15. Okay. We will now apply the concept of completing the square. We have here x squared plus 14x. We need to find a number that will be added to this side of the equation to make this side of this equation a perfect square trinomial. Now, what is this number? So, how to find this number is we just simply get the square of 1/2 of 14. Okay? 1/2 of 14 is 7. Then we square 7. That means 7 times 7 is 49. So therefore, the number to be added to this side of the equation is 49 to make this a perfect square trinomial. Now, since we added 49 at this side of the equation, of course, we will also add 49 at the right side of the equation. So our focus now is at the left side of the equation. So we now have this trinomial, which is x squared plus 14x plus 49, which is now a perfect square trinomial. So we can factor this out. Of course, the square root of x squared is x. So we have here x times x. And we copy the sign of the middle term, which is positive. That's why we have here both plus. And the square root of 49 is 7. That's why we have here both 7. Of course, when we add 7 plus 7, that would give us 14. Then at the right side of the equation, we have 15 plus 49, which is equal to 64. Now, since both are the same, x plus 7 times x plus 7, this can also be written as x plus 7 quantity squared. Of course, we copy 64. Now, we extract the square root since we have there the square. To cancel out this one, to eliminate this one, we need to extract square root at the left side of the equation and also extract square root at the right side of the equation. So this becomes the square root of x plus 7 quantity square equals the square root of 64. So, since we have now the square root and the square, this will be cancelled out. So, what remains at this side of the equation shall be x plus 7, and of course the square root of 64 is plus and minus 8, or that is positive and negative 8. Since this is square root, we have to indicate the two sign because positive 8 times positive 8 is equal to 64 and negative 8 times negative 8 is also equal to 64. This indicates two values of our variable. So when we break these two values, this will give us x plus 7 equals positive 8, the first value, and the second value is x plus 7 equals negative 8. Then we solve now for x. We use subtraction property of equality so that 7 shall be transferred to the right side of the equation. We subtract 7 here. Of course, we will also subtract 7 at the right side of the equation. So 7 minus 7 is cancelled out. So what shall remain here shall be x. Then 8 minus 7 is 1. So our first value is 1. X equals 1. Then let's proceed to the second value. We do the same. We use subtraction property of equality. So what remains at the left side shall be the x equals, we have here the negative 8 minus the 7. So negative 8 minus 7 is equal to negative 15. So therefore, our values for x, or that is the roots of this quadratic equation, is x equals 1 and x equals negative 15. Now to check, we go back to our original equation, x squared plus 14x minus 15 equals 0. The values are 1 and negative 15. First is we check for x equals 1. We substitute the value of x to this equation. So that's why we have here x squared. We change x, instead of writing x, we change that with 1. So that's why we have here 1 quantity squared plus 14 times the x is 1. Then we simplify. The square of 1 is of course 1. Then 14 times 1 is 14. Then 1 plus 14 is 15. Minus 15 is of course 0. So we got a balanced equation for the first value. Now let's proceed to our second value, which is negative 15. We do the same process. We substitute the value, which is negative 15, to the equation. So we have here negative 15 quantity squared plus we copy 14, then times our x is negative 15 minus 15 equals 0. The negative 15 squared is 225. Then 14 times negative 15 is negative 210. Minus 15 equals 0. So 225 minus 210 is 15. Minus 15 equals 0. So therefore, we got a balanced equation for both values of our x. Now let's proceed to our second example. The second example is x squared minus 5x plus 4 equals 0. The same process, see to it that the first term has the coefficient 1. So in this case, we already have the 1. So the same process, we need to isolate the constant. In this case, our constant is 4. We transfer this 1 to the right side of the equation by using subtraction property of equality. So we subtract 4 at the right side of the equation. We will also subtract 4 at the left side of the equation. So this will become, we copy the first term and the second term. So positive 4 minus 4 is 0. This will be cancelled out. So the remaining equation shall be x squared minus 5x. Since this is cancelled out, so this is 0. Then 0 minus 4 is negative 4. Now we will complete this side of the equation. To make this a perfect square trinomial, we need to find 1/2 of 5, which is 5 over 2, and the square of 5 over 2. The square of 5 over 2 is 25 over 4. Of course, we need to add this side of the equation, 25 over 4. And since we added here 25 over 4, we will also add 25 over 4 at the right side of the equation. Now, to factor this out, since this is now a perfect square trinomial, we need to factor this out. So we have the square root of x squared is x. So we have here the x and the x. Then we copy the sign of the middle term, which is negative. That's why they are all negative. And the square root of 25 over 4 is 5 over 2. And another here, 5 over 2. That's the square root of 25 is 5 and the square root of 4 is 2. That's why we have here 5 over 2 equals, at the right side of the equation, we have here negative 4 plus 25 over 4. Since this is a fraction and this is a whole number to have assumed to have a denominator 1, so our LCD shall be 4. Then we divide 4 divided by 1 is 4 times negative 4 is negative 16. Then we copy plus. Then 4 divided by 4 is 1 times 25 is 25. Then we express this one as the square of a binomial. So we can write this one as x minus 5 over 2 quantity squared equals. 16, that's negative 16 plus 25 is positive 9. Then we copy over 4. Now to eliminate our exponent here, which is 2, we need to extract the square root. That's why we have here the square root of x minus 5 over 2 quantity squared equals the square root of 9 over 4. So the square root is cancelled and the exponent. So what shall remain at this side of the equation shall be x minus 5 over 2. Then the square root of 9 over 4 is positive and negative 3 over 2. The square root of 9 is 3 and the square root of 4 is 2. This time we break the two values, the plus and minus. We have here the first value, x minus 5 over 2 equals the positive 3 over 2. And the second value, x minus 5 over 2 equals the negative 3 over 2. We now solve for the value of x. We use addition property of equality, so we will have x equals 3 over 2 plus 5 over 2. Since both of the same denominator, which is 2, so we just simply add directly the numerator and copy the common denominator. So 3 plus 5 is 8, then copy the common denominator is 2, then 8 divided by 2 is 4. So therefore, the first value is 4. Now let's proceed to the second value. The same process, we use addition property of equality. So that's why we have here, what remains at this side of the equation shall be the x. Then we have the negative 3 over 2, then plus 5 over 2. We have the same denominator, so we copy the common denominator and we perform the operation in the numerator. So we have here negative 3 plus 5 is positive 2, then positive 2 over 2 is positive 1. So therefore, the values are x equals 4 and x equals 1. Now let's proceed to our checking. We go back to our original equation and the values are 4 and 1. We substitute the first value, which is 4, to the equation. So we have 4 quantity raised to 2 minus 5 times 4 plus 4. So we change the values of x here with 4. So 4 squared is 16. 5, that is negative 5 times 4 is negative 20 plus 4 equals 0. So 16 minus 20 is negative 4 plus 4 is equal to 0. Another value, which is 1, substitute 1 to the equation. So that's why we have here 1 squared minus 5 times 1 plus 4 equals 0. 1 squared is 1. Negative 5 times 1 is negative 5 plus 4 equals 0. So 1 minus 5 is negative 4 plus 4, which is equal to 0. So 0 is equal to 0. Okay, that's it. I hope you have learned something from this video. And if you have any questions, you can just write in the comment section below. Or you can contact me through my Facebook account, which is found in the description box. So thank you and God bless.